No, there is no national electrical code limitation on the number of stores that Romex is limited to when wiring a residential home. Romex, which is a type of non-metallic sheathed cable also known as NMB, is permitted for use in residential buildings. Buildings can be up to 3 stories above grade, and this includes the basement. However, there are some additional requirements that must be met when using Romex in multi-story buildings. Firstly, in buildings with more than 3 stories above grade, Romex must be installed in metal raceways or other approved methods. This is to protect it from physical damage. Secondly, in buildings with 4 or more stories above grade, Romex must be installed in vertical shafts or riser ducts that are fire rated. These shafts and ducts must also be sealed at each floor level. Thirdly, Romex must be supported and secured at intervals not exceeding 4 feet and within 12 inches of every box, outlet, switch, or junction point. It's important to understand the specifics of these requirements. The need for metal raceways in buildings exceeding 3 stories stems from concerns about the increased risk of physical damage to the Romex cable. The higher the building, the greater the potential for accidental damage during construction or from other factors. Metal raceways provide a robust layer of protection, shielding the Romex from impacts, abrasions, and other potential hazards. Approved methods can include various types of conduit, such as electrical metallic tubing, or rigid metal conduit, or RMC, and intermediate metal conduit, or IMC. The specific type of raceway used will depend on the application and local code requirements. When dealing with buildings of 4 or more stories, the requirement for fire-rated vertical shafts or riser ducts addresses fire safety concerns. In the event of a fire, these shafts and ducts are designed to contain the spread of flames and smoke between floors. The fire rating indicates the amount of time the shaft or duct can withstand exposure to fire before failing. Sealing at each floor level is crucial to prevent the upward migration of fire and smoke through the shaft. This sealing is typically achieved using fire-stopping materials that expand when exposed to heat, effectively closing any gaps or openings. The support and securing of Romex at intervals not exceeding 4 feet and within 12 inches of every box, outlet, switch, or junction point is a standard requirement for all Romex installations, regardless of building height. This practice ensures that the cable is properly supported and prevents it from sagging or becoming damaged. Adequate support also reduces the strain on connections and terminations, minimizing the risk of electrical problems. In addition to these national electrical code requirements, some local building codes may have additional restrictions on the use of Romex in multi-story buildings. These local codes can vary significantly from one jurisdiction to another, so it is always important to check with your local building department before starting any electrical work. Local jurisdictions may impose stricter limitations on the use of Romex, such as prohibiting it altogether in certain types of multi-story buildings or requiring additional fire protection measures. These stricter requirements may be based on local fire safety concerns, building construction practices, or other factors. Checking with the local building department is essential to ensure compliance with all applicable codes and regulations. Before starting any electrical work, it is recommended to thoroughly review the National Electrical Code and any applicable local building codes. This review should include a detailed examination of the requirements for Romex installations, including the limitations on its use in multi-story buildings. If you have any questions or concerns about the code requirements, it is best to consult with a qualified electrical inspector or engineer. They can provide expert guidance on the proper methods for installing Romex in your specific application. When working with Romex, it is important to follow all safety precautions to prevent electrical shock and other hazards. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following all manufacturer's instructions for installing and handling the cable. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable performing electrical work yourself, it is recommended to hire a licensed electrician. A licensed electrician has the training and experience necessary to safely and properly install electrical wiring in accordance with all applicable codes and regulations. Consider the differences between non-metallic cable or NM cable, and other wiring methods. Non-metallic cable is a cost-effective and versatile wiring method that is commonly used in residential construction. It consists of two or more insulated conductors enclosed within a non-metallic sheath. Romex is a popular brand of non-metallic cable. Other wiring methods, such as metal conduit, armored cable, and wire in free air, offer different levels of protection and are suitable for different applications. Metal conduit provides the highest level of protection against physical damage and is often required in commercial and industrial settings. Armored cable offers a similar level of protection but is more flexible and easier to install. Wire in free air is typically used for overhead power lines and other outdoor applications. When selecting a wiring method, it is important to consider the specific requirements of the application, including the environmental conditions, the potential for physical damage, and the applicable codes and regulations. Consider the importance of proper grounding and bonding. Grounding and bonding are essential safety measures that help to prevent electrical shock and fire hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse into energizing the circuit. Bonding connects all metal parts of the electrical system together, creating a lower impedance path for fault current to flow. Proper grounding and bonding are required by the National Electrical Code and are essential for ensuring the safety of electrical systems. To expand upon the NEC requirements mentioned, let's delve deeper into the specific sections that govern Romex installations, particularly in the context of multi-story buildings. While there isn't a single explicit section that limits the number of stores for Romex use, the code provides guidelines that effectively create limitations based on building height and construction type. The primary concern, as highlighted earlier, is the protection of Romex from physical damage. The NEC addresses this concern in various sections depending on the specific application. For instance, NEC Section 334.12 outlines use is not permitted for non-metallic sheath cable. While it doesn't directly state a story limitation, it prohibits NM cable in certain types of buildings or locations where it is subject to physical damage. This is a crucial consideration for multi-story buildings, where the likelihood of damage increases with height and the complexity of the building structure. When the NEC requires Romex to be installed in metal raceways for buildings exceeding 3 stories, the relevant sections come into play. These sections dictate the types of raceways that are permitted, the methods for installing them, and the requirements for supporting and securing them. For example, NEC Section 344 covers rigid metal conduit, while Section 348 addresses electrical metallic tubing, or IMT. These sections provide detailed specifications for the materials, dimensions, and installation practices for each type of raceway. The requirement for fire-rated vertical shafts or riser ducts in buildings of 4 or more stories is closely tied to fire safety codes and standards. These codes, which are often adopted and enforced by local jurisdictions, specify the fire resistance ratings for various building components, including walls, floors, and shafts. The NEC defers to these fire safety codes when it comes to the design and installation of fire-rated shafts and ducts. The fire resistance rating is typically expressed in terms of the amount of time a component can withstand exposure to fire before failing. For example, a 1 hour fire-rated shaft can withstand 1 hour of continuous fire exposure without collapsing or allowing the passage of flames or smoke. The NEC also addresses the support and securing of Romex in Section 334.30. This section specifies the maximum intervals at which an M cable must be supported and secured, as well as the types of support methods that are permitted. The intent of these requirements is to prevent the cable from sagging or becoming damaged, which can lead to electrical problems. The local building department plays a vital role in enforcing the NEC and any applicable local codes. Before starting any electrical work, it is essential to obtain the necessary permits from the building department and to schedule inspections at various stages of the project. The building inspector will review the plans and specifications for the electrical work to ensure that they comply with all applicable codes. The inspector will also conduct on-site inspections to verify that the work is being performed in accordance with the approved plans and specifications. If any violations are found, the inspector will issue a notice of violation and require the contractor to correct the deficiencies. Compliance with local building codes is not only a legal requirement but also a critical step in ensuring the safety and quality of electrical installations. Proper grounding and bonding are governed by NEC Article 250. This article provides comprehensive requirements for grounding and bonding electrical systems to minimize the risk of electrical shock and fire hazards. Grounding involves connecting the electrical system to the earth, providing a path for fault current to flow back to the source. Bonding involves connecting all metal parts of the electrical system together, creating a low impedance path for fault current. The NEC specifies the types of grounding electrodes that are permitted, the methods for installing them, and the requirements for bonding various metal components. It also addresses the sizing of grounding and bonding conductors to ensure that they can safely carry the maximum available fault current. Understanding the different types of non-metallic cable is crucial for selecting the appropriate cable for a specific application. The most common type of NM cable is NMB, which is rated for 90 degrees Celsius dry and 60 degrees Celsius wet. NMB cable is suitable for most residential wiring applications. Another type of NM cable is NMC, which is designed for use in damp or corrosive environments. NMC cable has a moisture-resistant outer jacket that protects the conductors from moisture and chemicals. A third type of NM cable is UF, which is designed for underground installations. UF cable has a sunlight-resistant outer jacket that protects the conductors from ultraviolet radiation. When selecting NM cable, it is important to consider the environmental conditions in which it will be installed and to choose a cable that is rated for those conditions. When working with electrical systems, it is always important to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following all manufacturers' instructions for installing and handling electrical equipment. Energizing circuits before working on them is the most important safety precaution. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to verify that the circuit is de-energized using a voltage tester before touching any wires or components. Personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools, can help to protect workers from electrical shock and other hazards. Safety glasses can protect the eyes from flying debris, while gloves can protect the hands from electrical shock. Insulated tools can prevent workers from coming into contact with live electrical conductors. It is also important to follow all manufacturers' instructions for installing and handling electrical equipment. These instructions provide important information about the proper use of the equipment and can help to prevent accidents. Electrical work should only be performed by qualified individuals who have the training and experience necessary to safely and properly install electrical systems. Unqualified individuals should not attempt to perform electrical work, as this can be dangerous and can lead to serious injuries or even death. Furthermore, any modifications or alterations to existing electrical systems should be performed by a licensed electrician. A licensed electrician has the knowledge and skills necessary to ensure that the work is done safely and in accordance with all applicable codes and regulations. Working with electricity can be dangerous, but by following safe work practices and using appropriate personal protective equipment, the risks can be minimized. It is important to always prioritize safety when working with electrical systems. Beyond the requirements outlined in the National Electrical Code, several other factors can influence the selection and installation of Romex in residential buildings, particularly in multi-story structures. Firstly, building materials and construction methods play a significant role. For example, the presence of combustible materials, such as wood framing, may necessitate additional fire protection measures for Romex installations. Similarly, the design of the building's structural system can affect the routing and support of Romex cables. Secondly, environmental conditions can also impact the choice of wiring methods. In areas with high humidity or corrosive atmospheres, it may be necessary to use moisture-resistant or corrosion-resistant Romex cables or to install the cables in sealed raceways. Thirdly, the intended use of the building can influence the electrical requirements. For example, a multi-family dwelling with numerous appliances and electronic devices will typically have a higher electrical load than a single-family home. This may necessitate the use of larger conductors and more robust wiring methods. Finally, aesthetic considerations can also play a role in the selection of wiring methods. In some cases, homeowners may prefer to conceal Romex cables behind walls or ceilings to create a cleaner, more visually appealing appearance. This may require the use of special installation techniques or the selection of wiring methods that are easier to conceal. To ensure compliance with all applicable codes and regulations, it is essential to consult with a qualified electrical engineer or inspector during the design and planning stages of any electrical project. These professionals can provide expert guidance on the proper selection and installation of Romex and other wiring methods. They can also help to identify any potential hazards or code violations and recommend appropriate solutions. In addition to the technical aspects of Romex installations, it is also important to consider the long-term maintenance and reliability of the electrical system. Regular inspections and maintenance can help to identify and correct any potential problems before they lead to more serious issues. This can include checking for loose connections, damage to insulation, and other signs of wear and tear. It is also important to ensure that the electrical system is properly grounded and bonded to prevent electrical shock and fire hazards. By taking these steps, homeowners can help to ensure the safety and reliability of their electrical systems for years to come. In conclusion, while the National Electrical Code does not explicitly limit the number of stores for Romex use in residential buildings, it does impose requirements that effectively create limitations based on building height, construction type, and environmental conditions. Compliance with these requirements, as well as any applicable local codes, is essential for ensuring the safety and reliability of electrical installations. Consulting with qualified professionals and following safe work practices are also crucial for preventing accidents and ensuring the long-term performance of electrical systems. Remember to always prioritize safety when working with electricity and to seek expert guidance when needed. With careful planning, proper installation, and regular maintenance, Romex can be a safe and effective wiring method for residential buildings of all sizes.